So this is the first session for our final exam review. So let's take a look at it. We're going to start here with what is a one-to-one function. So let's remind ourselves that a one-to-one function passes both the vertical and horizontal line tests. Okay, so it needs to pass both the vertical and the horizontal line test to be one-to-one. And if a function is one-to-one, then it has an inverse. So another way of asking this exact same question would be, which one of these functions has an inverse? So this one passes the vertical line test, but not the horizontal. This one doesn't pass either. This one passes the horizontal line test, but not the vertical. This one passes the vertical line test, but not the horizontal. Nope, we finally found one. That one passes both the vertical and the horizontal line tests. This one again would pass the vertical, but not the horizontal. And this one would pass the horizontal, but not the vertical. So that one, the linear function, is the only one-to-one function here. And frequently, we will only see linear functions or rational functions here. So make sure you pass both the vertical and the horizontal line tests. Okay. All right. If we are given a rational, the first thing that you should do is check to see if it reduces. So we should ask ourselves, does this reduce? To do that, we're going to factor the denominator. Two numbers that multiply to a negative 27 and add to 6 are going to be c plus 9 and c minus 3. Nothing cancels here, which means that there are no holes. So right here under holes, I'm going to put D&E. Now, if I would have had a hole, I would have set that canceled factor equal to 0 to get the x value of the hole. Then I would have taken that x value and I would have plugged it back into my reduced function to get the y value of the hole. Okay. So the domain of this function would be all real numbers except the places that would make this denominator 0. So here, if I put a negative 9 right here, then this factor would be 0 and then the whole denominator would be 0. If I put a 3 right here, then this would be 0 and the whole denominator would be 0. So my two excluded values are going to be negative 9 and 3. So this would be c is a real number and c cannot be negative 9 and 3. And then in interval notation, we would say all the numbers to the left of negative 9, all the numbers in between negative 9 and 3, and all the numbers to the right of 3. And that negative 9 and 3, those are my vertical asymptotes. And so the c-intercepts would be the places where the numerator equals 0. So to find the c-intercepts, we would say 9c plus 10 equals 0. Because if a fraction has 0 in the numerator, then the whole thing is 0. So the c-intercepts would be at negative 10/9, 0. And then for the q of c-intercept, I'm going to come back up here to my original and I'm going to cover up everything that has a c in it because all of those would be 0. I'm going to have 10 over negative 27. So this would be 0, negative 10 over 27. And then last but not least here, we have a bigger degree in the denominator, which means that my horizontal asymptote is y equals 0. That means that both of these values are going to be 0. Now, hypothetically, let's just say this had been a c squared. Just pretend that for a second. Well, then I would use leading coefficients. So I would do 9 over 1. I would say y equals 9 is my horizontal asymptote. And then both of these would be a 9. So whatever this asymptote is, both of these should be that same value. If you have a bigger degree in the numerator, then you're going to use your polynomial rules. So this would be, as c approaches infinity, q of c, and as c approaches negative infinity, q of c. Okay. All right. So for any polynomial, you should always graph it first. Now, because I just did this with my Saturday class the other day, come on, take your time, calculator. Thank you. I already have this function here, so I don't have to worry about putting it in because I already have it there. All right. So its degree is 5 because that's its biggest degree, and its leading coefficient is 45 because that's the term in front of that with the biggest degree. So odd positive means end behavior looks like this. So this would be as t approaches infinity on this side, you're on the right side, you go up. So g of t goes to infinity. As t goes to negative infinity on the left, g of t goes down. All right, so now for zeros, that's where I need the graph. This thing looks really weird. There's something weird going on in the middle here. So let me identify the zeros that I for sure know. Okay, for sure know -2 and 1. Now, I'm going to zoom way in. Let me look at it again. There's something weird going on here between 0 and 1. So I'm going to zoom way in, and I'm going to change my window so that it's like -1 to 2, just around that 0 to 1 area, and make this -2 to 2. So I want to get really, really close to that weird stuff that's happening so that I can take a look at it. I feel like I still can't even really get a good idea of what's going on there. Let's get even closer. -1 to 1. It's a little better. It definitely crosses here, and then it comes around and turns here. So it's got two places where it's intersecting with the x-axis there. So what I'm going to do is I'm going to use the one of the calc functions. So press second and then calc. Second and then trace, excuse me, to get to calc. And let's see if we can have the calculator identify those zeros for us. So I want to figure out where that 0 is right there. So my left bound would be anywhere to the left. My right bound would be anywhere to the right. And I want to try to get that 0 right there. 0.2. All right, now let's try to get this 0 right here. So we're going to do that again, second and then trace to get to calc. We want a 0. So the left side and the right side. So that 1/3 has a multiplicity of 2 because it's a turn. And now really we didn't even need that. We only needed 3 because since this is a 5th degree. All right, let's see what would have happened. So here, let's just say we didn't realize that was multiplicity 2. I'm going to get rid of that. Pretend I didn't know that. I would have just started dividing these out. 45, 6, negative 118, 88, negative 23, 2. So let's take out the negative 2. It's negative 90, negative 86. Oh, that's a negative 2. So this would be a positive 172. 54.
It would be a negative 84, actually.
Negative 108. Going to be negative 20. Positive 40. What did I do?
Your 6 minus 2, right? 90 is negative 84.
45, negative 90. Ooh, that should have been 84. Lame. So 84 times 2, this would be 168. So that would be 50. That would be 100. That would be 12. Negative 12. That would be negative 24. Positive 24, because it's a negative 2. 1, negative 2, 0. Now let's do the 1. That's 45. Minus 14 would be 31. No, that's 12. This is a negative 31. Sorry, I'm just making sure that I'm all clear here with my negatives and positives. All right, 84. Jeez. Okay. Let me make this less messy so that I can actually read it. This was negative 84. This was positive 50, negative 12. Oh. Negative 39 times 1 plus 50 times 1. There we go. One-fifth times 45 is 9. It's negative 30. That's going to be negative 6. And then we can take out the 1/3 again. Now, I don't really have to do this last step because this is a quadratic and I could factor it. But I also know the 1/3, so let's take that out. Times 1/3 is 15. Negative 15 times 1/3 is 5. Negative 5. So then, if this was to the 5th, this would be 4, 3, 2, 1. So what I've got here is 45x minus 15 equals 0. So then my linear factors, if I wanted to write this as a product of linear factors, I could say, no, not x, t. T plus 2, t minus 1, t minus 1/5, t minus 1/3, and then this. Or I could have put another t minus 1/3 because if I solve this, I'll get 1/3. And so then the intercepts, the zeros, would be these. -2, 1, 1/5, and 1/3. And if I solve this, if I add the 15 and then divide by the 45, I'm going to get 1/3 again. Right. So I don't need to write 1/3 twice. It repeats. So those are all my zeros. And if those are my zeros, then the intercepts are just those points. And then the g of t intercept is the constant here. So if you're in standard form, that constant is always your y-intercept. Whatever that is. Because if you made all these t zeros, all of these other terms would zero out. They'd all go away. And you would be left with just this 2. Okay. Here, if we're looking at a transformation, remember inside affects horizontal movement. So the 7 would make the graph shift left 7 because a positive goes left and a negative goes right. And the outside is a vertical shift. So positive goes up. So this would be up 4. And a negative goes down. Okay. I'm going to rewrite this one over here where I have some room. Okay. So when we solve this, we need to get the log by itself first. So we'll add the 1. And then divide by the 10. And then we'll turn this into an exponential. So 2 to the 3rd equals 7x plus 5. And then 2 to the 3rd is 8. Subtract the 5. And divide by the 7. I feel like I got something different when I did this the other day. Nope, that's right. Okay. 3/7, and then 3/7 as a decimal, 0.4286. I just checked my answer by plugging it in, by the way. That's all I did. Was I plugged 3/7 in for x and got 29. I literally just went, hey, what is -1 plus 10 log base 2 of 7 times 3/7 plus 5? Oh, look, I guess that's right. I mean, if it were my final exam, I would probably do that for every equation that I have, but that's just me. All right, another polynomials question. So let's write the polynomial here. So here I have a 0 at -2. What letter do they use here? Is that a T? That's not a T. So T equals -2. It crosses straight, which means its multiplicity is 1. I have a 0 here at T equals 1. It crosses curved, so that means its multiplicity is 3. And I have a 0 here at T equals 3. It bounces, so that means its multiplicity is 2. So the only thing that I don't know right now is my leading coefficient. So I'm going to put an A as a placeholder for that. And say, okay, I know T plus 2, multiplicity 1. I know T minus 1, multiplicity 3. And T minus 3, multiplicity 2. Right? Because of my behavior at my zeros. I also know the point 0, 2. So I'm going to make y2 and t0. And I'm going to solve for a. So let's see what all this nonsense turns out to be. -18. So I wind up with 2 equals -18a. Divide both sides by -18, and I'm going to get a is -1/9. Right, 2 over 18 will reduce to 1/9. And so then my final equation with my correct leading coefficient will be q of t equals -1/9. T plus 2, t minus 1 cubed, t minus 3 squared. Domain is left to right. We go from -2 to 1. Open circle gets a parenthesis, closed circle gets a bracket. So that's my domain. Ranges from bottom to top. So this would be 0 on the y, and it tops out at 4. So open circle again means that I put a parenthesis around that. And since the 4 is a point on the graph, anything on the line would be considered a closed circle. So the 4 gets a parenthesis, or a bracket, excuse me. I feel like compared to all these other questions, that one doesn't, it doesn't fit. Anyway. Okay, so here we have 3 functions, q, f, and m. And first we need to do q plus f of 2. So that's q of 2 plus f of 2. And so Q of 2 is 1. And then F of 2 is 3. So Q of 2 plus F of 2 would be 4. Now F of 1 minus, why did I put an equal sign there? Minus M of 1. Okay, so F of 1 is 1. And M of 1, 7 times 1, 2 times 1 squared minus 2. 8. So then this would be a negative 7. Q of 0 times M of 0. Q of 0 is 3. M of 0 is going to be negative 2, because if I plug in a 0 here and here, they're both going to go away and leave me with just this negative 2. So that's negative 6. And then F of 5 over Q of 5. So F of 5 is 5. Q of 5 is 4. Okay. Now for this one, remember for the inside, you want to do the opposite of what you see and in the opposite order. And for the outside, you want to do exactly what you see and in that order. So for example, we're going to take this 3, and here you want to multiply by 3.9 and then subtract 6. But we need to do the opposite of those and in the opposite order. So I'm going to add the 6.6 and then divide by 3.9. 2.46. And that is my new inside. And then for the outside, you're going to do exactly what you see and in that order. So I'm going to do negative 6 times 5.8, and then I'm going to add 12.8. And that's my new outside. So again, on the inside, the opposite of what you see and in the opposite PEMDAS order. And on the outside, what you see and in the right order. Okay. All right. So when we solve this log equation, in order to be able to do this, we're going to multiply these because we have to combine these logs before we can do anything else. So we're going to multiply the t and the t plus 5 and make it log base 2 of t squared plus 5t. Okay, because when you add these, you multiply these. And so then this would become 2 to the 4 equals t squared plus 5t. And so that's 16. So we'll get t squared plus 5t minus 16. What did I say? 16, right, 12. That doesn't factor. So we're going to have to do the quadratic formula, which is incredibly annoying, but, you know, sort of expected. So negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 16, 89 over 2 times 1. Not asking me for exact values, so I'm going to get my 2 decimals here. So let's do -5 plus the square root of 89 divided by 2, and then -5 minus the square root of 89 divided by 2. So 2, 1, 4 decimal places. Well, this 9 is going to round up this 9, and this 9 is going to then round up this. So this is actually, that actually is 4 decimal places because it would be 7, 0. Now, I don't know if you remember me telling you this, but logs have a domain of only the positives. So I am not allowed to put a negative in a log. So if I put that negative 7.217 right here, this would throw an error. So that means this is not a valid solution. And my only solution is the 2.217. So make sure you're double checking. And it's not the fact that that's negative that's the problem. It's the fact that I would be doing the log of a negative that's a problem. So like if this had been t plus 10, I could have plugged in a -7. Okay. So always be checking that, please. Okay. And then here, remember, I don't pay any attention to this until I'm at the end. So I'm going to break this out and make it log base 3 of r to the 9/7, because remember, my exponent is my numerator and my index on my root is my denominator, minus log base 3 of y to the 11, minus log base 3 of t to the 6th. Anything in the numerator gets a plus, anything in the denominator gets a minus. And then I'm going to hop out my exponents. So 9/7 log base 3 of r, 11 log base 3 of y, 6 log base 3 of t. Excuse me. And then log base 3 of r is 13.69. Log base 3 of y is 5.1. Log base 3 of t is 0.64. And now that's just a calculator thing. So let's plug it in. There we go. 9/7, 13.69. Oops. 11. 5.1. 6.64. I cut off how many decimal points, so let's just do 3. Negative 42.339. Okay. I want to stop there because that was a lot of information that I just threw at you, and I do not want to throw any more at you. We're going to do the other 3 pages of this on Wednesday.